All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development 1100 C# programming class, I've been doing a series of introductory type videos based on the book that we're using for the class, that being Murachs C# 8th edition. I'm up to Chapter 13 of 22, and as you can see, it's how to work with indexers, delegates, events, and operators. I do want to mention, I'm going to show you this quickly and then come right back. All right. Last year, or when I taught this class, okay, we had a test just on Chapter 12. Then I took the information on Chapters 13, 14, 15, and 16, kind of bundled it together and made one test. Probably that's the way I'll do it this year. I don't know for sure. All right, but I just wanted you to at least hear that, if nothing else. All right, so they mentioned in the last chapter we learned some specific skills for creating and working with classes. Now we'll learn additional ones. So as you can see, we'll have an introduction to the product list class. We'll talk about indexers, delegates, and events, how to overload operators, and finally we'll end up with an enhanced version of the product maintenance application. Now, I don't know if I've mentioned this to you or not, but what I'm planning on doing this semester, probably starting, believe it or not, day one, is we're going to be working to create our own type of payroll application in C#. And we're going to start very, very simplistically. We'll add things to it as we go. All right, but I just want you to hear that because I want you to know what's going on. I mean, I've got a vision of what I want to do here, and we'll see if it works or not. Okay? All right. So it says, as you may recall, the product maintenance app in Chapter 12 used a variable of type list product to store product objects. All right. So to demonstrate, it says, the chapter uses a new class named product list. All right, so it's got the code right here, or the explanation, but let's take a look at the code itself right here. So as it says, this is the code for a simple product list class. I always love that. And it's not just Murach, but it's any company or anybody that comes in for something like this and says that something is simple. When you're first learning it, very few things are simple, all right? But we've got a class called product list. You can see that the product list is going to contain a list of type product, all right, which we created the product.cs earlier, and it'll be called products. This right here, this is our constructor. So there's just a single constructor. It takes in no parameters, and basically it's going to create a new product. So everything in there is going to be set equal to the default values. All right. We also have a variable called count, which will keep track of how many products we have. All right. You've got an add method, and you'll notice that add method is overloaded. The first one just does an add because you pass in an entire product. The second one, rather than passing in a product, you're passing in the product a field at a time. So we create a new product in there, and then we add the product P, as they call it, to our products list. All right. We've got to get product by index. And index basically may not be that important right now, but as we go on and on in the class, it'll take more and more importance. If we have an array of products, each product in the array will have its own index. So the first product will be product 0, the second product will be products 1, etc. So that's how we can get a product based off of its index. Remove is simply that. For that fill method, what we're doing is we're adding it basically to our database file. And for save, we're basically saving it out there. All right. So it says figure 13.2 shows the specification for the enhanced version. So this is some of the stuff that they're going to put into the product list. All right, and especially these indexers that are right here. So as mentioned, it says the class provides two indexers that let you access a product based on either its index, in other words, its position or place, or by its product code. That is supposing, if you're going to do it by product code, all right, that is expecting that each product will have a unique product code. Besides the indexers, it says there the enhanced product list class includes a plus operator that adds a product to the list and a minus operator that removes or deletes it. Those are what are called overloaded operators. Now you might say, well, what do you mean? All right. Well, when you think of plus, most of the time you think of addition. And that is kind of what we're doing here. But rather than the addition of a number, we're adding a product to a list of products. And for the minus, you think of subtracting one number from another and getting the difference. But in here, when we use the minus operator on a product, we are finding the product in the list and then removing it. Finally, as it says, this class uses a delegate named changeHandler and an event named changed. The delegate is, as it says, is going to wire event handlers to the changed event. The product list raises this event when the contents of the product change due to the product being added to, updated in, or removed from a list. All right. So as it says there, the product maintenance app uses this event to determine when it should save the product and refresh the list box. So they're using stuff in here where previously they had done it one way and now they're doing it in another way. All right. And again, I'm not the one to say that's a good thing, that's a bad thing. It's a thing. All right. So it says in the topics that follow, you'll learn two skills for working with indexers. First, you'll learn how to code an indexer without and with expression bodies. Then we'll learn how to throw an argument exception if the argument that's passed into it isn't valid. This is about as heavy as anything that we've covered so far in this semester. So as they mention here, the next figure shows an indexer is a special type of property that's used with classes to represent collections of items. It allows other code access to an item by specifying an index value. Now, I'll give you an example, not a great one, but one we could kind of use. When you think about it, all right, one way that I could probably reference each and every one of you, there'd be a couple ways at least, but everybody who's in the class, one way we could do it is when you register at Rankin, you're all given a Rankin ID number. All right, that basically could be used as your index. All right, now the first thing I thought of was you each have a unique, probably at least, have a unique address. Probably there aren't two of you that live together, but it would be possible. So that wouldn't really work well as an index value. Something like a Rankin ID number would work well. An indexer, when you do it as it says there, can be provided with a getter and a setter. A class can have any number of indexers as long as the parameter lists are different, so you can overload these as well. I don't want to get into this in too much detail. All right. I don't know what happened here. Let's see. There we go. And I don't want you to worry about this too much. All right. Like I said, this is about as heavy as it gets. There's only a certain amount of stuff in the amount of time we have to go over this unit that I can get across to you, and I think get across in a way that you'll understand it. Indexers are right on the fringe of that stuff. As far as you may be able to understand them, you may not. All right. I mean, sometimes I have a little problem explaining some of the stuff. Do I totally understand them? I understand what they're supposed to be doing. All right. But again, the idea is they give you a way to grab, if you've got a list of something like a list of products, they give you a way to grab any individual product that you have a desire for, to either add to a list, update in a current one in a list, or remove a current one in a list. All right. When you code properties and methods, it says it's often a good idea to check that the arguments passed to them are valid. We already did this. Not exactly the way they'll show it here, but if you remember, in the product class, we had 3 fields. We had a string for code and a string for description. We did the is present on both of those. We also had a decimal for the price of the book, or the price of the product, rather. And we had on there an is decimal check. But as it says here, argument exceptions can be handled with this stuff too. All right, when you are working with indexers. All right, why would you care about it? Well, the first one is throws an argument exception. It checks the range. All right, so it says if I is less than 0, so you're passing in an index. So let's say you've got 10 things in there, which would probably be 0 through 9. If you put in a number less than 0, so if you were to pass -1 in here, or you passed in, let's say, 100, which is greater than our count, you could throw an argument out of range exception. All right, otherwise you would return that. So there's a lot of ways in which this can be used. Now, the key thing in there is what you want to make sure is if you want to check apples, you pass in apples and you pass in a valid apple. All right? And all I'm saying in here is that if you pass in arguments, they should be the right type and they should be within the right range. And that's what they're saying in here as well. All right. In addition to fields, properties, indexers, methods, and constructors, a class can also define delegates and events. All right, now we're going to talk about a delegate in a second, but before we do, think about what a delegate is, okay? Let's pretend, and I hope this doesn't happen all summer long, but let's pretend that I am sick for a day. In fact, even a better example. Last summer, I did not teach during the summer semester. Mr. Gudmeston, did. At the St. Louis campus. He had a section of the AWD 1000 Web Development Technologies class. All right, I worked on other things during the summer. I worked on getting my courses done for fall, etc. Okay? But there were a couple times during the semester that Mr. G said, hey, I'm going to be gone for a couple days. He had a family situation come up, etc. And he asked if I would take over his class. So in other words, he delegated the authority of his class to me. Now, in all those cases, they were just lab days. But if the student had a question, they could ask me. All right. And if you look at this, it says a delegate is created from a class and can refer to methods with a specific return type. You can think of a delegate as a pointer to a method with a given signature. So you can indirectly, call the method through the delegate. It's kind of the same thing I just wanted to tell you. All right, kind of the same thing I just went over. I'm not going to go over this. I'm not even going to go over it much in class because, again, it is very, very confusing. All right? And when you start talking about pointers and the like, I know the C programming language. That's one of the first languages that I learned, and it works with pointers, and it can be unbelievably hard to understand exactly what's going on. So I'm just going to leave it at that. All right. An event is a signal that an action has occurred. You've actually worked with events all semester. For example, when you click a button, you've been working with a button click event. Okay? You can define your own events by declaring a delegate that will be used to refer to the event handler for the event. So they're showing that in here. Again, like I said, this is, in my humble opinion, this is about as hard as this class gets, and I'm not going to spend much time on this. We will talk about it a little in class, but not much. All right. The next thing that's discussed in here are anonymous methods. If a method is anonymous, what that means it doesn't have a name. All right. And when you use lambda expressions, it's a special operator. You've actually seen it before, but we haven't talked much about it. The lambda operator is a greater than sign, an equal sign followed by a greater than sign, like right here. And normally, when you write something, you can either write or create it as a, quote, regular expression or as a lambda expression. And that's what they're talking about in here. Again, we'll talk about this in class. I just don't want to. Right now, it's so easy to get people confused, and that's not my intention. All right. The next thing that's discussed in here are overloaded operators. All right. Now, what does that mean? You know what the plus and the minus is. You know what what these operators here all are. You know what they are. They are used a certain way, but normally they're used, if they're unary, they're used on on a number. If they're binary, there's a number on the left and a number on the right. But you can also overload those operators to make them work with objects. All right. Not only that, there's an equals method that you can use with objects, and a get hash code you can use with objects. Just going to leave these both at that. We will talk about them a little bit in the classroom. Again, here they're overloading the plus sign. All right. Any of those that we looked at can be overloaded. All right. The chapter ends then with this enhanced version of the product maintenance application. This is pretty difficult. The good news is it runs just like the other one did. The bad news is now they've added delegates and they've added events, all right, which I think can be proved to be very confusing. Again, we will look at this stuff in class. If we look at it in class and it doesn't make a boatload of sense, that really and truly is to be expected. All right, a lot of the things in chapters 13, 14, 15, and 16 are going to be confusing to many people. And there will be probably times that you'll find that the description I give you of something may not be stellar either. All right. And that's it. So I'm going to stop right here. And when we go on, we will go right into chapter 14. This is an important chapter because we will talk in here about inheritance. Now, when you think of genetic inheritance, I've given this example before. Maybe it's a good one, maybe it's not. But typically the way life works is if you have a parent, a father with a big nose who marries a mother with a big nose, and they have a child, normally at least, the child will have a big nose. Doesn't always work that way, I understand, but normally it does. It's not like the child could, the child's got two things they can do, three things. They can live with what they've got, or really two things, or they can get a nose job. It's not like they can take the nose off and put a different one on. You can do that when you're programming with inheritance. And that's what we're going to talk about amongst other things, in the next chapter. So I'll be back with that in a few minutes.